So now let's look at the Taylor polynomials for some examples about Taylor polynomials. The first example is the f of x equals e to the x. Okay, so we are very familiar with this function, right? This is the exponential function. So we want to know what is the nth Taylor polynomial for a function, for this function f at x equals 0. So that means the x not equals 0, right? So we know that f of x, the nth Taylor polynomial can be written as, the nth Taylor polynomial can be written as p sub n, which is equal to the summation I from 0 to n of f the i's derivative at x naught over I factorial times x minus x naught to the I, right? So here x naught equals 0, x naught equals 0, so it becomes the summation I from 0 to 1 f, take the i's derivative at 0, then over I factorial, right, x minus 0, so x to the I power. And we notice that if we take the i's derivative of this function f, because it's e to the x, so it's always e to the x, right? Then f, the i's derivative at 0, which is equal to e to the 0, which is equal to 1. So we use this fact, we can have it's equal to summation I from 0 to n, which is 1 over I factorial times x to the I. So that means it's equal to I equals 0, which is equal to 1 plus x squared over 2 factorial plus x to the nth power over n factorial. So this is the nth polynomial, Taylor polynomial for this function f at x naught. And we, from the previous proposition, we know that this polynomial and this f have contact of order n at x equals 0. So that means when near x equals x0, and these two functions should be very close to each other, right? So how close they are? So the idea is, let's look at the difference between these two functions. Okay, fx minus p sub n. Right? In many cases, this difference will approach 0 when n approaches infinity, but for some cases will not. Okay, there are some functions, certain functions, the limit of this difference may not be 0. You can check it online. There are many functions you have. But we give a definition for this difference, which is denoted by r sub n. So you will have, so this is called the remainder. So here, this is called the remainder, the nth remainder. So we can also write as f of x is equal to the nth polynomial plus the nth remainder. In the next part, we will study this remainder.